Today we will discuss about a Bode plot, introduction and some examples with respect to the Bode plot. What do you mean Bode plot? Introduction for the Bode plot. The plot of magnitude and the phase angle versus frequency may represent a sinusoidal transfer function. H.W. Bode, this is the name of the scientist, used the logarithmic scale to study the magnitude of the transfer function and the frequency variable. The particular logarithmic plot is called as a Bode plot as it is invented by the H.W. Bode. Another definition for the Bode plot is a Bode magnitude plot is a graph of log magnitude against log frequency, often used in signal processing to show the transfer function or frequency response of a linear time invariant system. What is the purpose of Bode plot? First purpose is to draw the frequency response of open loop transfer function. Second purpose, to find the closed loop system stability, means we can find out the stability of the system, whether the system is stable, unstable, marginally stable. Then to find the relative stability by using GM and PM, means gain margin and phase margin. In a later slides we will discuss what I mean by gain margin and phase margin. Actually, the Bode plot consists of two plots or the two parts, magnitude plot and phase plot. Here it is, we will discuss the phase and gain crossover frequency. The gain crossover frequency is the frequency at which the magnitude of the open loop transfer function is unity, and the phase crossover frequency is the frequency at which the phase of the open loop transfer function is 180 degree. Graphically also we will see. Another thing with respect to the stability analysis using Bode plot is the frequency at which the phase plot is having the phase of 180 degree is known as phase crossover frequency. It is denoted by omega pc. The unit for that is radian per second. Same it is for the gain crossover frequency. It is for the magnitude plot. Is having the magnitude of a 0 dB is known as a gain crossover frequency. It is denoted by omega gc, and the unit of that is also radian per second. Now we'll see the graphical representation for the gain and the phase margin. Here it is. As I told you, Bode plot is having the two different parts. First is a magnitude plot, another one is a phase plot. Magnitude plot is dB versus frequency, and the phase is for the angle versus frequency. Then here it is. In this diagram, where we'll first discuss for the first magnitude plot. In the diagram, it shows the 0 dB, minus 20 dB, plus 20 dB. Then here it is a one blue line shows. That blue line is nothing but a magnitude plot for a given transfer function. Later in the example, we will discuss that. Then, if I want to find out the gain margin, what I have supposed to do? I have to consider wherever that 180 degree line for the phase angle, we have to draw the vertical line for that. And after drawing the vertical line, you have to measure that line for in between the 0 to 20 dB. That particular it is nothing but a gain margin, that is a minus 20 dB. Means difference between that blue line and the 0 dB is for the particular 180 degree crossing line is a minus 20 dB. So here it is a minus 20 dB is gain margin. Then we'll go for a phase angle. Here it is also phase angle, that phase plot is shown by the blue line. How to find out phase margin? Here it is, you have to draw the another vertical line which will crosses the 0 dB wherever the blue line crosses the 0 dB. You have to draw the vertical line for that. You have to find out where that phase, that particular blue line crosses for the phase angle. And that particular, what is the difference between that blue line and the 180 degree? That is nothing but your phase margin. Here it is, this is a phase margin is minus 9, means difference between that blue line and the 180 degree line crosses that particular vertical line is a minus 9 degree. Both are the negative, so the system is unstable. Same thing we'll discuss here, but here it is, instead of considering gain margin, phase margin, we'll go for the phase crossover frequency. What is that particular frequency? And the gain crossover frequency. Particular line, what is a vertical line we are drawing there? What is that? As we are drawing the graph, that of magnitude plot and the phase plot versus logarithmic omega frequency, then whatever the particular that vertical line is, that is particular frequency is nothing but a phase crossover frequency, and wherever the we are getting the phase margin, that is a gain crossover frequency. This is another representation. It shows a gain margin, phase margin, and frequency with respect to that. Then, how to find out the stability? This is the second purpose of the system that Bode plot is. We can find out the stability of the system. Here it is. How to find out the stability? If both gain margin and phase margin are positive, then as shown in the diagram, we know the process for how to find out the gain margin and the phase margin as we discussed in the first graph. There, if both are the positive, it means that the system is a stable system. Another, here it is a next unstable. If both are the negative, system is unstable. And marginally stable means if both are the GM and the PM are 0, it means that the system is marginally stable. Once we completed our example, and if we completed our plot for the magnitude and the phase plot, we can easily recognize whether the system is stable, unstable, or the marginally stable. This is the semi-log paper where we are going to draw the magnitude plot and the phase plot. We can say it is a semi-log paper. What is the basic procedure for that? First step is whatever the transfer function is provided for us, that definitely that step that transfer function is terms of S, we have to convert into the j omega, and to convert into the frequency means we have to convert into the frequency domain. Then write the magnitude and convert into the dB. Means for each and every, means as we know that a transfer function consists of the zeros, poles, simple zeros, all you have to convert into the magnitude and then convert into the dB. There is a procedure for converting into the dB and finding the magnitude. In the latter part we will discuss that. Then find out the angle for each and every, whatever the factors are there. As I told you, constant is there, pole is there, zeros are there, simple poles are there, simple zeros are there. For each and every one constant, magnitude and angle is there. We have to find out with respect to that, whatever the particular method for that. Then vary omega from minimum to maximum value and draw the approximate magnitude and phase plot. This is the basic procedure for drawing the Bode plot. As I told you, there are the different factors are present in the transfer function. We know the transfer function for the any open loop or the closed loop transfer function. Here it is, it consists of the constant k, then there is a pole at origin, then the multiple pole at origin, zero at origin, multiple zeros at origin, then it consists of the factor of the terms, then the first order system, first order pole, then multiple pole, first order zeros, multiple zeros, quadratic poles, quadratic zeros. Means these many factors are present in the transfer function. For each factor there is a one magnitude formula and the angle formula. Then the angle is there. If we'll consider that, it will be very easy to draw the Bode plot. These are the factors. We'll go for there are the 5 columns. First one is the type of the form. Then there is a particular, what is that, it is in terms of the transfer function, that j omega 1 upon j omega is there, 1 upon j omega n is there, constant is there, multiple poles are there, multiple zeros are there. This is the symbol for that. Then what is the slope for the particular basic factor, then what is the magnitude for that, and what is the phase for that. Once we'll completed this, it will be very easy to draw the Bode plot, because all these are the factors. It will be constant for the particular factor. First, constant k is there, slope is 0 always, the magnitude is 20 log k, and what is the phase angle? Phase angle is 0. For example, if we are having the constant of 20 in our example, then the slope is 0. How to find out the magnitude for that? 20 log 20 means k is your 20. So 20, if 12 is there, it means that your k is 12. 20 log of 12 you can find out, will you get answer in a dB. And don't forget, phase angle for the constant is always 0. In the same way, second one is 0 at origin. If you are having the 0 in our transfer function and it has a 0 at origin, it means that j omega is there, slope is 20, 20 dB, and here it is a magnitude is 20 log of omega. Whatever that particular frequency is present in that, you have to find out the magnitude for that. And phase angle is always 90 degree for the zero at origin. If n number of poles are present at the at origin, same here is 20 into n, then the 20 n log of omega and the 90 into n. The same way, pole at origin opposite of the zeros, 1 upon j omega, then slope is a minus 20, magnitude is minus 20 log of omega, means minus 20 dB slope is there, and the magnitude is minus 20 log omega, and angle, phase angle is always minus 90. Same, it is n number of poles at origin. Then single zero means 1 plus j omega, and slope is 20. Here it is 0 for the omega is less than 1 upon tau, and the 20 log omega is for omega greater than 1 upon t, and the angle is 90 for the omega is greater than the 1 upon t, otherwise 0. Same way, here it is all the factors and the particular, the magnitude and the phase angle for that. Then each every that whatever the factors are present, we will go for the that diagram with the Bode plot for each and every constant terms or the factors. First one is the constant gain k. If the k is present, then you have to find out the magnitude for that. 20 log of 12, 20, 15, whatever is there, you will get a 1 dB. You have to draw the line for that. Here it is, if the k is equal to 1, definitely 0 dB line will be there. Then if a k is greater than 1, you will get a plus dB answer. If the k or the that k is in between, if k is in between 0 less than 1 and less than 0 less than k less than 1, then you will get a minus dB answer. Then the pole at origin, same here, pole at origin we have discussed. If a pole at origin, you will get a minus 20 dB. Here it is a slope. So here it is two different things are shown. The if one pole at origin or the n number of poles will be at origin, then here it is, we can see how to draw the slope minus 20. It means what? Here it is, as I shown you the semi-log paper, it contains the 5 cycles, 0.1, 1, 10, 100, 1000. In this way you can mark that 5 cycles. First cycle is at 0.1, another one is at 1, next one is at a 10, then 100 and 1000 is there. That is your log omega. Then I want to draw the slope line minus 20. Then what you have to do, minus 20 dB means upper to downward direction, upper to downward to upward direction. Here it is. Then here it is, you have to mark the that symbols for that magnitude, that is a 0 dB, minus 20, plus 20, in this way on the semi-log paper. Then minus 20 means what? You have to mark 0.1 and the 1, and wherever the plus 20 is, you have to mark them, and you have to draw one line which will crosses the 1, then 10. If you want to draw it a continue, then the after 10 then will be 100, it will crosses the next minus 40. In the same way you can draw for the minus 20 also. Same it is applicable for the 0 at origin. Here it is a plus 20, 0.1, 1, 10, minus 20 line, 10 to 1, then 0.1 is there, minus 20, it means that this is the slope of the plus 20 dB. Next, simple pole at origin, same here it is applicable for that, whichever that slope is there, minus 20 dB decade, you can draw it. It is a simple 0 at origin, plus 20 dB decade. Then what are the steps to sketch the Bode plot? Express given g of s, h of s into time constant form. Draw a line of a 20 log k dB. Draw a line of appropriate slope representing poles or zeros at the origin passing through the intersection point of omega is equal to 1 and the 0 dB. Shift this intersection point on a 20 log k line and draw parallel line to the line drawn in step 3. It means that wherever the constant k is there, for that first you have to draw the line and then shift a line parallel to the particular 0 dB of the line. Then change the slope of this line at various corner frequencies. Corner frequencies means number of poles and number of zeros are present. In our example, based on that you have to change the slope for the every step. Then prepare the phase angle plot and the table. For the phase angle you have to prepare one table for by varying the omega. Then prepare a table and the resultant phase plot you can draw. We'll discuss one example with respect to that. A unity feedback system is g of s is given 80 divided by s into bracket s into bracket s plus 8 in another bracket s plus 20. Draw the Bode plot for this and determine the GM and the PM. Here it is. In the solution, first is what is the first step? Convert into the j omega and the format is, and then find out the how many factors are present. First factor is present is a k, that is a 80. Then you have to find out the what is a dB for that. Then 80 not, here it is as we are converted into j omega, that 80 is converted into 2, therefore k is equal to 2, 20 log of 2 is a 6 dB. Then here it is, for each and every step you have to find out the magnitude and angle. Number of poles are present, number of zeros are present here. For the each everything we have a table for that. You have to refer that table and you have to find out the dB. For each here it is a pole is present, so minus 20 dB, minus 20 dB and the minus 20 dB, that the slopes are there for all. Then phase angle table is there. As I told you, number of terms are present. Based on that you have to consider the phase angle. 1 upon j omega is present, minus tan inverse omega by 2 minus tan inverse omega by 20 it is present. You have to take a resultant of that. I'm changing the omega by 0.2, 2, 8, 10, 20, 40, 80 in this way. You can change this angle also by considering 0.1, 0.2, 5, 10 in this way. Omega is variable, depending on your choice you can change it, and you have to find out the answer for that 1 upon j omega by putting the value of the omega here. 1 upon j omega, then tan inverse of omega. We know that for 1 upon j omega always angle is minus 90 degree. Already we have listed in a basic factor table. Then here it is minus tan inverse of omega by 2 means, it means that you have to put the omega value as a 0.2. It means minus tan inverse 0.2 divided by 2. By calculator you can calculate it as a minus 5.7. Then resultant means you have to take addition of all these. Minus 90 degree plus minus 5.7 plus minus 0.57. Addition of that resultant is a minus 96.27. In this way you have to prepare a table for the phase angle. And this is the final Bode plot. For the first one is a half of that is for a magnitude, another one is for the phase. And in this way, as we have discussed how to find out the gain margin and a phase margin, we have to consider the 0 dB line and the draw vertical line for that. Then here it is, which will crosses the 180 degree, that particular, that is nothing but a PM. And another thing is, wherever the 180 degree crosses, you have to draw the vertical line for the GM. Wherever there is a in between 0 dB and the 20 dB, that is your gain margin. Then we'll go for another example. Sketch the Bode plot for the transfer function g of s is equal to k s square divided by 1 plus 0.2 s in bracket 1 plus 0.02 s. Determine the system gain k for the gain crossover frequency to be a 5 radian per second. Here it is, we'll consider the k is equal to 1. So g of s is equal to s square divided by 1 plus 0.2 s in bracket 1 plus 0.02 into s. Two different corner frequencies are, that is a 5 and a 50. How to calculate? Here it is 1 plus 0.2 is there. If we'll take it out, here it is a 1 divided by 5 will be there. 1 divided by 5 into s will be there, and 1 divided by 50 into s will be there. So 5 and the 50 is there. Then we have to list out prepare one table for the magnitude plot. Factor is a square, corner frequency is not there, so straight line will be there. Here it is 40 dB is there, and which will passes through the omega is equal to 1. Why 40 dB? Because a square is there, n into 20 into 2 we have listed in a table also. We can refer that table, basic factor. So 2 into 20 dB, it is a 40 dB. Then 1 upon 1 plus 0.2 s omega 1, corner frequency is omega 1 is equal to 5. So for this, we are having the straight line constant of the minus 20 dB. Already we know that 1 upon, if it is there is a minus 20 dB slope is there. For this also minus 20 dB, and the omega 2 is a 50. Then magnitude plot is shown in the figure. We'll see the figure. Then in that, this is the magnitude plot for this, which will crosses the, wherever it crosses the 0 dB, we can draw the gain margin and the phase margin for that. Then the magnitude plot shown, if the gain crossover frequency is required to be 5 radian seconds, then it must crosses the 0 dB line at, but here it is for this plot, it passes down by the 20 dB. Therefore 20 log k is equal to minus 20. It means k is equal to 0.04. Then another example, it's a very simple example. Draw the Bode plot for a system having g of s into h of s is equal to 100 divided by s into bracket s plus 1 and s plus 2. Maximum times the 99%. This type of examples will be there in the exam. Find out gain margin, phase margin, gain crossover frequency, phase crossover frequency. Then the g of s into h of s is equal to 100 into bracket. Here it's what we have done. We have taken 2 outside from the for the arrangement of the equation. So 1 upon 2 multiplied by numerator as well as by the numerator. Therefore, here it is g of s into h of s is equal to 50 divided by s plus 1. 1 plus 0.5 into s is there. Then we've listed the factors. 50 is there, constant is there. We know that constant how to 20 log of whatever the constant is there. Here it is a 20 log of 50 is equal to 34 dB. 1 upon s, nothing, only the 20 dB line is there. Corner frequency is not there. For this corner frequency is there 1 upon 1 plus s. 1 is there. Straight line is of a minus 20 dB. And then 1 upon 1 plus 0.5 s. There is a 2 corner frequency. Straight line minus 20 dB passes through the omega is equal to 2. Then same phase plot, how many that factors are present based on that. First one is for the minus 90, second one is a minus tan inverse of omega, and the third one is a minus tan inverse of omega. 0.5 s is there, so 0.5 omega is there, and the resultant will get answer here. And based on that we can draw the, here it is a magnitude plot, only we have to for the follow that whatever the slope is there. Here it is we have listed. First slope is 34 dB. So here it is a 34. It will 34 means it will be started with a 54. Here it is. Then next one is a minus 40, minus 40. Then here it is the 40 dB. Why 40 40? Because here it is 20. This minus 20 is 0 and then the minus 20 is there. So here it is minus 20, minus 20, minus 40 is there. So here it is a minus 40 dB line is there. This is the phase plot and the magnitude. Then phase plot. Here it is whatever the phase is. That is minus 90, minus 98.6, minus 107. All this we have to mark it and we have to draw the line and follow the procedure for finding the gain margin and phase margin. Here it is for this example. We are having the gain crossover frequency and the phase crossover frequency 1.40 and gain crossover frequency 4.45. Gain margin is the 24.5 dB. The phase margin is a 53 degree. This is another example for this. A unity feedback control system. G of s is given. Same example. We have to first take it in the format. Here it is by taking in the format 14.2857 in bracket 1 plus 0.1 into s divided by square into bracket 1 plus 0.5 into s in bracket 1 plus 0.1428 into s. Here k is this. So find out definitely easy. 20 log k. It is a 23 dB. Then the straight line will passes through the 23 dB. Then the range of the frequencies and the resultant slopes. Here it is a 2. You can consider the 0.6 or the 2 or the 0.147. Then the range of the frequencies is 2, 7, 7, 10 and the 10 less than omega less than the infinity. Minus 40, minus 40. For this is a minus 20. So minus 40, minus 20, minus 60. Earlier is for the 7 less than omega less than 10 is. Earlier is a minus 60 and for this is a minus 20. So there is a minus 80. Then here it is for the 10 less than omega less than infinity, it is slope is a plus 20. So minus 80 plus 20 is a minus 60. So starting point is 20 log of k minus 20 log of omega n minus 20 minus 40 is there. So 23 minus 40 is a 63 means your Bode plot for the magnitude will be starts with a 63 dB. Then here it is the angle 1 upon j omega square is there. Another tan inverse of 0.5 omega, tan inverse of 0.148 omega is there. Then the tan inverse of 0.1 j omega is there. Resultant we can find out by easily varying the value of the omega 0.22 in this way. This is the final as we have seen in this diagram. Here it is. first it will be start with the 60 degree, we want a 40 dB. It means what? You have to draw the line which will started with the 63 and end up to minus 40 means point 0.1, then the point 1 1, as I told you here it is point 0.1 1 10, we have to mark it. Minus 40 means there is a difference of the minus 40 lines, means 63 minus 40 63, then here it is the 63, then 53, 43, 33. You have to mark the 33 at 1. We want to 40 dB at, here it is from this to this, here it is a 43 which you have to mark. Then the next is, but at that time you have to refer the what is the omega. Here it is, as we have listed what is omega. Omega 0 to 2 there is a minus 40, then 2 to 7 there is a minus 60 slope we want. Then here it is omega is, here it is omega, it is a 1 10 1 10 100 in this way. Then 2 to 7, here it is omega 1 is there, then the 2 3 4 5 6 7 8 9, and here it is a 10. You have to mark the 2 point, and 2 to 7 there we want a 60 minus 60 dB slope. You have to mark the line, here it is. Then the next one is we want a minus 80, it is in between 7 to 10, and then you have to mark, here it is, where is the 7, you have to mark that 7. You have to draw the line very lightly, and then finally you mark the dark lines. Then here it is the minus 80 means 7 to 10 we want to minus 80. You have to mark the scale for the minus 80, but wherever we want to stop, you have to stop over there only, up to the 10 only I want to stop. Then the last one we want to minus 60, that is a 10 to infinity. Then this is the final slope. Same it is applicable for the phase margin, phase angle also. Mark the points and the draw the line. Then we want to find out the gain margin and phase margin. What is the procedure? Wherever the 180 degree crosses, here it is, wherever the 0 dB crosses, you have to mark the vertical line. Wherever the 180 and that crosses line, that is the 182, that wherever the cross that particular phase plot, that is particular your phase margin, that is a minus 68, I think so, here 68. Then phase margin, how to find out the phase margin? Same procedure is there. Wherever it crosses the 180, here it is what happened, it this line or this phase plot is not crosses the 180 line. It means that gain margin is a minus infinity, minus infinity. So as a gain margin is negative, phase margin is also negative. The system is unstable system. Thank you.